Hi, good evening. In last lesson, we talked about multiplying a polynomial and a monomial, but now we are getting into multiplying polynomials. It could be a binomial and a binomial, or a binomial and a trinomial, or special products of binomials. These are the three different things that we're going to be learning in this lesson, lesson 14.4. Multiplying a binomial and a binomial, multiplying a binomial and a trinomial, and special products of binomials. The special products are two types. One is product of a sum and a difference, and squaring a binomial. We will learn about all these things when we get to that topic. Alright, so let's start with multiplying a binomial and a binomial. There are different methods I can use to multiply a binomial and a binomial. I'm going to be showing you all different methods. Whichever one that speaks to you, you can use that method. All right, you don't have to use a specific method only. You can use any method that's easier for you to understand and that speaks to you. Okay, so I'm going to be using the same example in all three methods, so you can see that whichever way you do, you arrive at the same answer. All right, so the first method I'm going to be using is distributive property. First of all, I'm seeing that this is a binomial and this is also a binomial. It is separated by parentheses, like I just told you in the first class. And the one that is the operation that is happening between these two binomials is a multiplication, because I don't see any other operation there. So I'm multiplying a binomial and a binomial. The distributive property is, say if I had one number to distribute, say I had 3 times x plus 5, I just distribute the 3 to both of them. So I get 3 times x, which is 3x, and 3 times 5 is 15. So I get my algebraic expression. But here I have x squared plus 3 being distributed to x plus 2. So first I am distributing the x squared to both of them. So it is x squared times x plus 2 plus 3 times x plus 2. So this is distributive property done in multiple steps. All right, so the first one I'm distributing is the first term to the second binomial and the second term to the second binomial. So x squared times x plus 2 and 3 times x plus 2. Now again I have to do a distributive property one more time. X squared times x will give me x cubed, and x squared times 2 will give me 2x squared, plus 3 times x will give me 3x, and 3 times 2 will give me a 6. So I got 4 different terms now. None of them are alike. If I end up with any like terms, I'm going to be combining the like terms and simplifying the polynomial that I end up with. So the answer is x cubed plus 2x squared plus 3x plus 6. So this is distributive property using distributive property. I am distributing one term at a time to the second polynomial. So first term that I'm distributing is the x squared to x plus 2 and plus 3 times x plus 2. So I have these terms. So that's method 1, using distributive property. The second method, it is called the FOIL method. Okay, remember this FOIL method is only applicable to multiplying a binomial by another binomial. It is not applicable to all polynomial multiplications, whereas the distributive property you can use for all polynomial multiplications. But this one, it's only for binomial and a binomial multiplication. Okay, so I'm using the same example, x squared plus 3 times x plus 2. So FOIL is an acronym for first terms, outer terms, inner terms, and last terms. So what this means is, first I'm multiplying the first terms of both polynomials. So the first term here is x squared, the first term here is x. So I'm multiplying the first terms. X squared times x is going to give me x cubed. All right. So next is the outer terms. The outer terms are x squared and 2. So I'm multiplying the outer terms. So x squared times 2 is going to give me 2x squared. All right. Now comes your inner terms. Inner terms are 3 and x. So first thing is I need to write the binomial side by side. Only then this makes sense. So first terms, outer terms, the inner terms are 3 and x. So I have 3 times x. 3 times x is going to give me 3x. Now the last terms are 3 and 2. So 3 times 2 is going to give me 6. Now I'm not done yet. I just multiplied them. Now I have to put them all together as a single polynomial. So this is a positive x cubed. So I have x cubed. This is a positive 2x squared. So it is plus 2x squared. This is a positive 3x. So plus 3x. And this is a positive 6. So it's plus 6. So I got my answer. It is the same as what I got when I did using distributive property. X cubed plus 2x squared plus 3x plus 6. Both are same answers. So this is method 2, FOIL method. Okay, so this is only applicable for a binomial and a binomial multiplication. Please keep that in mind. All right. So the next method, my favorite one, is table method. Okay, so I have a binomial and I have another binomial. So my table has that many rows and that many columns depending on what my polynomial is. This method is also applicable for all polynomial multiplications. Doesn't matter how big your polynomial is, you can use this method to multiply them. All right. So here I have a binomial. So I can have 2 rows. One is for the first term and one is for the second term. And this is also a binomial. So I'm going to have 2 columns. One is for the first term and one is for the second term. I constructed my 2 by 2 square, right? So I have a table here and I want to multiply them now. So x squared times x is going to give me x cubed. X squared times 2 is going to give me 2x squared. 3 times x is going to give me 3x. 3 times 2 is going to give me 6. Care should be taken that you are only multiplying what's outside the box. Sometimes you end up multiplying 3 times 2x squared and put the answer here. Please make sure that you are multiplying only what's outside of the box. Okay, so x squared times x, x cubed, x squared times 2, 2x squared, 3 times x, 3x, 3 times 2 is 6. So you got all the 4 terms. Now I want to put all of them together. Doesn't matter which order you put in, but I'm just going to write them. X cubed, it's a positive x cubed, so that's a positive 2x squared. That's a positive 3x. That's a positive 6. So I got my answer. Okay, so it's the same as what we got earlier. So the table method and the distributive property method you can use for any polynomial with multiplication. Table method and distributive property method you can use for any polynomial multiplication. Can be used for any polynomial multiplication. But the FOIL method is only for binomial and a binomial. Okay, FOIL is only for binomial and a binomial multiplication. Binomial and a binomial multiplication. Very important fact. Most of the students make a mistake there. So please remember that. Okay. So that's binomial and a binomial multiplication. The next one we're going to look at is multiplying binomial and a trinomial. Alright, binomial and a trinomial. As I said, we learned three different methods earlier, right? Out of which two can be used for any multiplication, whereas the FOIL can be used only for binomial and a binomial. So here I have a binomial multiplying a trinomial. So I'm going to either use a distributive property method or the table method. Remember, FOIL is not applicable in this situation. So I'm going to use distributive property method. Alright. Distributive property is I am distributing the first term to the second polynomial first. So it is x times x squared minus 5x plus 4 plus I am distributing the 2 to the second polynomial. So I have 2 times x squared minus 5x plus 4. This is the first distributive property. Now I still have to distribute it one more time. I'm distributing the x to everybody, right? So x times x squared is x cubed. X times negative 5x is negative 5x squared. Yeah, x times x is x squared, negative 5x squared. X times 4 is 4x. I've distributed that. X times 4 is 4x. Now 2 times x squared is positive 2x squared. 2 times negative 5x. 2 times negative 5 is negative 10x. 2 times 4 is 8. So I distributed it all. I got this. Now I want to see if there are any like terms that I can combine. I see x cubed. I don't have any other x cubed, so I'm going to write it. I see negative 5x squared and a positive 2x squared. So negative 5 plus 2 is a negative 3x squared. Taken care of that. Remember, we did this in our first class. I have another 4x and a negative 10x, which are alike. 4x minus 10x is negative 6x. And all I left is with 8. So my answer is x cubed minus 3x squared minus 6x plus 8. Remember, I am doing repeated distribution. First I distributed the x to the second polynomial, and then I distributed the 2 to the second polynomial. I got this. Now here in turn I am distributing the x to everybody. Got this, and I distributed the 2 to everybody, and I got this, and I combined the like terms to get my final polynomial. Alright, so this is using distributive property. The second method I'm going to use is the table method, which is my favorite. Here I have a binomial and a trinomial. So I'm going to put my binomial to the left. So I have 2 rows, one for the term x and one for the term positive 2. So I have x plus 2. And I have 3 columns because it's a trinomial. So I have one for x squared and one for negative 5x and one for the positive 4. Remember, I'm writing it along with the sign. Please make sure that you do that so that you don't miss out any sign while multiplying. Alright, so I have 2 columns and 2 rows and 3 columns. So now I want to multiply. X times x squared, x cubed. Remember, you're only multiplying what's outside. X times negative 5x. It's negative 5x squared. X times 4 is 4x. Now 2 times x squared is 2x squared. 2 times negative 5x is negative 10x. And 2 times 4 is 8. Now I multiplied everybody. Now I want to put all the terms that I got by multiplying the 2 into one single polynomial. So I start with x cubed minus 5x squared. That's a positive 4x. That's a positive 2x squared. That's a negative 10x. And a positive 8. I got one long polynomial. Now I want to combine like terms. I have this x cubed. There is no other x cubed, so I'm going to just write it as is. Taken care of that. I have negative 5x squared and a positive 2x squared. So negative 5 plus 2 will give me a negative 3x squared. I've taken care of that. I have 4x minus 10x. So that's a negative 6x. Taken care of that. And a positive 8. Alright. So I have combined all the like terms and I got my polynomial, which has 4 terms now. Alright. So the answer, if I compare with what I heard earlier using the distributive property method, I got the same thing. Alright. My favorite method is the table method. I can't do any mistake. I can't go anywhere wrong. So I would use that if I were you. Alright. So here is 2 methods that we learned about how to multiply a binomial and a trinomial. Alright. So out of the 3 topics that we talked about, we have covered 2 topics. We have seen multiplying binomial and a binomial, and we have seen multiplying a binomial and a trinomial. Alright. The next topic is special products. Special products of binomials. Alright. So special products are, first is squaring a binomial, the square of a binomial. Here I would like to mention something. Say we square numbers, right? We square integers. Say I have 3 square. You know 3 square is 9, right? So 9, I call it a perfect square. It's a perfect square because this is a number that I got by squaring a whole number, right? This is a perfect square. Similarly, there are a lot of other perfect squares, like 4 is a perfect square, 16 is a perfect square, 25 is a perfect square. So whenever I square a whole number, I'm getting a perfect square, right? So here, I'm going to be squaring a binomial. Okay, so the tendency for you guys to do is, you just distribute the power to everybody. You say it is x squared plus 25. Okay, so this is not the same. Not true. Okay, x plus 5 the whole square is not the same as x squared plus 25. Okay, so we will just prove that in a bit. Alright, so instead of doing x plus 5 the whole square, I cannot distribute the power to everybody because this is not the same as 5x to the power of 2, in which case I can distribute the power to everybody. It is 5 squared times x squared, which will give me 25x squared. Okay, so care should be taken to make for not making this mistake. It is not equal to x squared plus 25. So what is it then? So I have x plus 5 the whole square. When you have 3 square is 3 times 3, right? So I'm going to be expanding it out. So that's my first step. X plus 5 the whole square, I'm going to be expanding it out. X plus 5 times x plus 5. Okay, so x plus 5 times x plus 5. So now this is a binomial times binomial. So remember, we learned 3 different methods to multiply a binomial and a binomial. Like I said, my favorite method is my table method, so I'm going to be using the table method. If you guys want to use the FOIL method or the distributive property method, I don't have a problem with that. So here the first binomial is x plus 5 and the second binomial is x plus 5. Alright, so x times x, x squared, x times 5 is 5x, 5 times x is also 5x, 5 times 5 is 25. So if I put all these terms together, the ones that I got after multiplying, so I get x squared plus 5x plus 5x, that's x squared, plus 5x plus 5x plus 25. So my combine the like terms, I have x squared plus 10x plus 25. So x plus 5 the whole square was not x squared plus 25. X plus 5 the whole square is x squared plus 10x plus 25. Alright, so that's my trinomial. Alright, it's a quadratic trinomial. So I got this by squaring a binomial. Alright, so I had a binomial and I squared it. So my binomial, it could be an addition, meaning the two terms could be added, or the two terms could be subtracted like this. So it could be an x plus 5 the whole square, or it could be an x minus 5 the whole square. So this is example number 2, where I'm going to be squaring a binomial which is not a sum of two terms, but it is a difference of two terms. Okay, so here also x minus 5 the whole square is not the same as x squared minus 25. Alright, or x squared plus 25 if you square the negative 5. If you put that into your squaring, so it's not the same. Alright, so do not make the mistake by just distributing the power to both of them. Alright, so this is not the same. So x minus 5 the whole square. So my first step would be to expand it out. So x minus 5 times x minus 5. Alright, now this is a binomial times binomial. So just for the sake of it, I'm going to use the FOIL method here. So FOIL, first terms. The first terms are x and x. So x times x is going to give me x squared. And the outer terms are x and negative 5. So x times negative 5, x times negative 5 is a negative 5x. And inner terms are negative 5 and x. So it's negative 5 times x is going to give me another negative 5x. And now the last terms. The last terms are negative 5 and a negative 5. So it's negative 5 times negative 5, which will give me a positive 25. Alright, so I want to put all of them together as one single polynomial. So I have x squared minus 5x minus 5x plus 25. So x squared minus 5x minus 5x is going to give me a negative 10x. So x squared minus 10x plus 25. So this is also a quadratic trinomial, but I got it by squaring a difference of a binomial. Okay, so this is a difference of two terms. Alright, I'm squaring a binomial which is the difference of two terms. So it could be an x plus 5, or it could be an x minus 5, or it could be any other two terms. It could be 2p plus 3 or 2p minus 3. Okay, so it could be anything. So that is squaring a binomial. Alright, so now comes the second special type, which is the product of a sum and a difference. Alright, what do I mean by product of a sum and a difference? We saw that my binomial could be addition of two terms or subtraction of two terms. Alright, so now I am multiplying one binomial which is addition of two terms and another binomial which is subtraction of the same two terms. I'm not talking about two different binomials here. I'm talking about the same binomial, but one is adding the two terms, the other one is subtracting the two terms. So this is x plus 5 times x minus 5. So I'm going to use my table method, which is my favorite. So this is x plus 5. This is x minus 5. So this is one binomial and I have the other binomial. X times x is x squared and x times negative 5 is negative 5x. Positive 5 times x is positive 5x. And positive 5 times negative 5 is going to give me a negative 25. Alright, now I want to put all the terms that I got by writing it as a single polynomial. So I got x squared minus 5x plus 5x minus 25. Now combining like terms, the negative 5x and the positive 5x is going to cancel out each other. Alright, so I get an answer which is x squared minus 25. So this is a binomial that I got by multiplying two binomials. Okay, so I have this product. Okay, so each product that I got has got its own name. Alright, so let's take a look at what the name of the product is. Say I have this perfect squares, right? When I square a whole number, I get perfect squares. So here I'm squaring a binomial. So whatever product I get, it's called a perfect square trinomial. Perfect square trinomial. I squared a binomial and I got a perfect square trinomial. I squared a binomial again. This is also a perfect square trinomial. A perfect square trinomial. Okay, it's just a special case. Here I had a product of a sum and a difference, and I got an answer which is a binomial. If you notice, this is a square number, a perfect square number. If I knew what x is, x squared is a perfect square. 25 is also a perfect square, and I'm subtracting the two, right? This is x squared minus 25. This is a perfect square, this is also a perfect square, and I'm subtracting the two. So this is called difference of two squares. Difference of two squares. Because next module we will be factoring them, meaning we are going to go from here to here. Okay, so we're going to go back, reverse our steps, and go back to where we started. So we need to remember these names. So difference of two squares. So x squared minus 25, perfect square, a perfect square, difference of two squares. Okay, so when I multiply, when I do special products, squaring a binomial gives rise to a perfect square trinomial, and multiplying a sum and a difference gives rise to a difference of two squares. Okay, so those are different multiplications that we have.